Welcome everyone to our, I think, 13th seminar in the series of the Quantum Delft monthly seminar series. I'm really pleased today to be introducing the ImpaQt consortium largely from Delft. When I started in this role 16 months ago or so, this organization, this collaboration of companies in Delft and beyond was already in existence, and it was a really good testament to the collaborative nature and the environment that we have here amongst the Delft startup community. So I'm very pleased to welcome the whole team to today to give us some insights into what the ImpaQt consortium are doing and the results that they've achieved so far. So to start with, I'm going to introduce Dan Kaltenbrouw. He is the COO and co-founder of Delft Circuits. And today he's going to give us a quick introduction to the ImpaQt group. And then we're going to go through all the different members. Are going to give a short introduction to their parts of the project. So welcome, Dan. Over to you.
Yes, thank you so much, Dan. So welcome everyone. I will first briefly introduce myself. Indeed, I'm one of the founders of Delft Circuits and the COO of Delft Circuits. But in this position, I'm more, one of the co-founders of the ImpaQt consortium, if you will, and in charge of the external affairs here. Can we start the slideshow? Perfect. Okay, I hope you can all see this well. So I will introduce all the different parties, but before I do that, I will introduce why we do ImpaQt and what it means to us. And it's all about the value chain approach for the quantum industry. So next slide, please. So what do we mean with the value chain approach? Well, it's easiest to look at this in contrast, especially in the quantum industry, in contrast to the monolithic approach, where we see the monolithic approach as basically a one party builds the entire system approach, which is very clear in the way Google and IBM do that. And I think that's a very good approach if you want, if you put a lot of money there and you have a lot of good people together. But we want to do it very differently. We actually have various part suppliers here in Delft, but also in the Netherlands, where we actually put all our products together to build one system. So it's not one party from top down gathering all the stuff and making it. It's rather all the product suppliers putting their systems together. So if we go to the next slide, please. So who are we and how does it work? Let me start from the bottom, basically the motor or the working horse, if you will, of the quantum system. We need a quantum processor, and those are delivered by QuantWare. Then Demcon delivers the shielding around the quantum processor, which is then connected with the I/O or the cabling of Delft Circuits, which connects it through the cryogenic system all the way outside to the room temperature environment, and then to the control electronics of Qblox, which is then connected with the control framework of Orange Quantum Systems, and the algorithm provider here is Q&Co, or actually this has now become Pascal. So this is what we do. But why is this important for us? Well, for us, and now if I talk about the cabling for my company itself, we can test our cabling, we can test our products, which all works fine. But the actual test is, of course, really on a quantum computer. Because if it works on a VNA or on a nice setup, it's not the same as in a real relevant environment. So we build actually our relevant environment where we can all test our products. And by doing so, we have to hook them up together. We have to see that it works. And by doing so, we actually can work towards standards together, which then can later on be used in the industry. And this very much enhances and strengthens our local ecosystem. So what have we done? It's interesting that what Dan says, he talks about 16 months ago, and it was also about the same time that the first product started. This was the ImpaQt 1 project, and this was a 1 qubit system with off-the-shelf components. And basically in 3 months, we put everything together and got 1 qubit to run. So that was really cool and really exciting for ourselves. And then I thought, okay, we have to bring this to the next level. We have to put this further. So we decided to go for a 5 qubit demonstrator setup, where we really have the proof of product of the different consortium members. And that was starting, we started developing it last fall, and now actually it's running in the TNO lab. So yeah, that's where we have 5 qubits now together, and Torsten will tell about that more, and actually the whole presentation will be about that. And then our next step will be towards a 25 qubit demonstrator, where we really look for scaling. So if we look a bit further in the future, and we go to the next slide, what do we want to do? One of the things is obviously stronger and stronger QPUs, 100 and 1000 qubits. But of course, here it's not only about the number of qubits, it's also about the quality. But again, this we need to do together. We need to have the whole system working together. And for that, we need a permanent lab. But also externally, what does it mean for other parties? Well, one of the things we are working on and we're clarifying very clearly are those interfaces between the different components, which can then become standards. And we're thinking about sort of swappability of our products, where another supplier in the long run could swap in a certain product, and which, as long as it's ImpaQt compatible, then and has this quality label, it should be swappable. So that's where we go. And yeah, I think if you go to the next slide, then that's it. And then, yes, let's continue with the chips of QuantWare. And this is Alessandro, I think.
Yep. Thank you very much, Dan. Of course, I'm completely excited by what Dan just said. So here I'm going to present a little bit about QuantWare, of which I'm the CTO. Next slide. Yeah. So at QuantWare, we are doing definitely the quantum hardware, and more specifically, hardware that stays at millikelvin stage of dilution refrigerator, and we are also at the bottom of the quantum stack. So we definitely like to interface and collaborate with many other players of the stack. What we offer is good qubits on short lead times, and this is getting quite some traction. People really liking that they can just order processors for a small experiment or larger experiments. And so next slide, we put the Soprano qubit on the market a few months ago. We've seen really good traction. And since the March meeting, we also released a 25 qubit device called Demcon Qu&Co. Again, customizable, and it's, in my opinion, just an intermediate step with 50, 100, and 1000 qubits, and that's our core development at the moment. So we should be ready with 50 qubits by 2023. Up to now, in the NanoNISQ is a 5 qubit device, Soprano, where we demonstrated good T1, good control, also gate fidelities. So we are happy with going to the larger scale as soon as possible. And being part of ImpaQt is definitely the best way to test things with the closest partners. Next. Yeah, so it's my pleasure to introduce also Vincent, or Geert here. I see.
Thank you very much. Yeah, it's me. Thank you very much. Yes, I would like to talk a little bit about Demcon first. So first of all, Demcon really enjoys working with the startup companies in this endeavor. It's very interesting. Actually, Demcon also started out, like all companies, as a startup in 1993 in Enschede. At the moment, we are a little bit bigger, 1,000 employees now. And we have locations around the Netherlands, but also around the globe. We have our main important points are not only R&D, but we also deliver products. But for this project, we are really into it, in getting something to the next level on the world of shielding. Our main instance is exactly that. Thank you very much. So what we actually do is I didn't really ask already for the slide over, but it's okay, I think. What we do is shielding the jewelry, as I call it here. It's important to keep the outside out and to keep excuse me, a little bit hampering here on the excuse me, one sec. So what you here see is actually the end result, especially on the left side. So in the middle picture you see the chip or part of it being installed, and on the left side you don't see anything really, but that's the case. That's what we need to do. And so we designed the shielding not from scratch. So if you go to the next slide. So we started out from, that's what we do. We do not only mechanical engineering or mechatronical engineering, we also do calculations. And what you see here on the left side is a finite element calculation that we did, starting from the old situation before the project to the new one. So the color scale is not completely convincing, but the shielding improvement is really a big thing. And we did it, for example, by some geometric alterations, also shifting a little bit the, you can see it on the top, for example, on the right side, adding an extra can there for extra shielding. And we go ahead and made it, and I think it's really successfully installed now in the project. And that's basically my 2 cents for now, I guess, keeping it short.
Yes, thank you. So my name is Daniel. I'm an R&D engineer at Delft Circuits, and Delft Circuits aims to provide a full product for I/O of quantum computers. So when you have your nice Soprano qubit and you have your shielding all worked out, you still need to bring your room temperature signals, of course, to your quantum chip. And you should really think, and there's a lot to think about when you think about your I/O. You have to think about filtering, what type of cabling platform should I use? Should I use normal metal or superconductors? You have to think about the heat load, which becomes especially important when you want to scale up to more qubits. If you want to go from 5 to 25, you already have to think about a little bit how much heat you're going to introduce into your cryogenic system. And so at Delft Circuits, we try to make this easy for the whole value chain. We worry about those issues and then give you a full product. So here on the left, I show what you should think about when you think about I/O. Very broadly speaking, you have your input, which you call here the drive line, and you have your readout lines. So these have 2 different functions. With the drive, you drive your qubits, you do your operations, and with the readout, you read out the states of your qubits every time. And I will focus mostly here on the drive line. And in this drawing, you can see it already has a few different types of filters. You have the low pass filter, you have the attenuator, infrared filter before you reach the quantum chip. And in this drawing also we made the part superconducting. You also have to think about that part. And so at Delft Circuits, the main thing that we do, what's very different from the traditional coaxial approach where you have to put in each line individually and each filter individually, we bring the whole thing into one manageable package. So on the picture on the right, you can see an example. This is a cable which has attenuators, low pass filters, and infrared filters all integrated in a single assembly. And this is not for 1 line, it's for 8 lines. So you can see you can very quickly go to a very scalable solution with our product compared to coaxial solutions. And what's more, because of the design of our lines, the amount of metal that we use is a lot lower. And that means that also the heat load that you add by adding these cables into your fridge is a lot lower. So it's not only takes up less space, it also lowers the heat load of your entire system with many, many lines. And in the next slide, I'll show you a nice example of why this filtering is so important. And you really need to think about it carefully if you want to make the most of the nice qubits that you have. So in the ImpaQt project, we did 2 cooldowns with the same qubits. And on the left side, this was the first cooldown. And this was actually born out of necessity. We didn't have the filtering back then. But we said, okay, let's try and see what happens. So we used our flux lines, which is a line that you use to control your qubit in a certain way. And it did not have the infrared filtering that you normally put there. And then what we saw is a T1, which was okay-ish, 23 microseconds, but especially the T2 times, the T2 Ramsey and the T2 Echo were very bad. And so we did a second cooldown on the same qubits, and then we added our cryoflex cabling with the integrated infrared filtering. And you have to see this infrared filtering here, that we combine it with superconducting cable. This is really unique, a unique project. You cannot get anywhere else. But you see an enormous increase in the T2 Echo. And this is really due to the added filtering. It just shows that if you think about your filtering carefully, you can get much more out of your qubits. So this is basically what we do at Delft Circuits. And together with our partners, we can show really nice results. And this is a nice example from this project specifically. So those were my 2 slides. So I'd like to give it over to Qblox, to Damas.
Damas, you're muted. You're on mute.
I'm so sorry. Thank you so much.
No problem.
Let me quickly recap. My name is Damas de Jong, and I'm representing Qblox. The main focus of Qblox is to create control electronics for quantum computers. And over the course of this presentation, I would like to tell you how our core values sort of fit into the quantum ecosystem as a whole, and of course, how they work together with the ImpaQt projects that we have been running here. So in the graph that you see on the slide on the bottom right sort of shows the current state of the art of quantum computers right now. And as of yet, the results are not yet more impressive than what we could do with very powerful classical computers. For that, we need quantum advantage, or we need to simply say better, more qubits, and we need to have those qubits with a lower error rate. So Qblox was founded to solve the control electronics aspect of this problem. It was founded in 2019 because we realized that many PhD students all over the world were solving the same problems over and over again. And by providing these solutions of control electronics as a company, we can provide some stability and continuity, something that's very hard to do usually in an academic settings, to labs all over the world, such that the scientists in those labs can focus on the science rather than the nitty-gritty electronics development. So the vision we had is to develop a control stack that sits in between the computer that is operated by some high-level language like Python. We send the essential commands over to our control stack that then connects to the cables that were presented in the previous presentation to send our drive signals down to the qubit and read out what the qubit is doing, or the qubits are doing, to in this way control the quantum computer. And the product we developed is, we call that the cluster. And that's what you see in the bottom left. And in the remainder of the presentation, I will tell you about the 3 core values that we incorporated in the construction of this cluster. So if we could go to the next slide, please. The first core principle that we adhere to at Qblox is the analog excellence. So if you remember the graph from the previous slide, it showed that when the error rates are too high, we will never be able to reach the quantum advantage. And the error rate is greatly influenced by the amount of noise that's injected onto your qubit. So by keeping this noise very low, we get the best performance from all of our qubits in the project, and thereby the longest coherence times and the best quantum computations. And we do this by comparing the noise behavior of our equipment to the other equipment that we could get our hands on, to compare if indeed we can use this term that we are doing well in terms of analog performance. And indeed we can. We have shown that our equipment shows best-in-class noise performance. And not only that, we can multiplex on different channels together, so we can read out multiple qubits at the same time, which is very time efficient, and we can do so without creating unwanted spurs in the frequency spectrum. So this allows us to address specifically which qubits we want to talk to without accidentally operating on any other qubits. Secondly, on the next slide, we are providing a system that's massively scalable and inherently flexible. Each module that you see in the cluster can be exchanged for whatever the needs are for your quantum computation. And in doing so, we have the, I'm sorry. Okay. In doing so, you can, for each module, tell whether you want to operate in the baseband regime, so that's the 0 to 300 megahertz, or the 2 to 18 gigahertz regime. And you can specify the number of input and output channels that you want on the modules to really get the system that's optimal for your specific qubit platform, and to get the most suitable hardware for the specific QPU that you're operating. And by having this modular approach, and by really stressing the amount of space that each module takes, we reach a density of being able to control 1 qubit per liter of volume. And that means that a system, a chip of 100 qubits could be controlled by a rack that you see in the bottom left. So that is our massively scalable component of the company. Finally, on the next slide, we provide a fully integrated system. And I won't bore you with the exact details that are on this slides in view of time, but not only do we provide very detailed control of the waveforms that we create with our equipment, but by incorporating an upmixing stage to the module itself, we really enable the user to create up to 18 gigahertz frequencies from a single module. And this is really an advantage of using the equipment we have to be able, in such a small volume, create this high frequencies without any other external components needed. Finally, when you scale the number of qubits, you will definitely reach that it's hard to keep your control of all your qubits in check. The programs that you need to write for the entire controlled stacks gets more convoluted, and this is why, together with Orange Quantum Systems, we develop Quantify, where rather than specifying what the control pulses should be, we are actually specifying which quantum experiment we want to run on a more abstract level. So in the image on the bottom, I show a block diagram of a quantum experiment. And by using Quantify, that's then compiled into the waveforms that are needed for this experiment, sent to the devices, and thereby you can execute your experiment without worrying too much about the details. So this solution has now been used all over the world, but especially, of course, within the NanoNISQ ImpaQt project to enable the measurement of 5 qubits simultaneously. And with that, I would like to give it to the next speaker, Torsten from Orange Quantum Systems.
So I hope I'm not muted. Let me get started right away. I took over a nice snapshot from Damas' earlier slides. Indeed, the whole community and ecosystem still has to work on making better qubits and more of them. And we kind of summarize it as Orange Quantum Systems is willing to tackle the quantum device characterization bottleneck. And why is that urgent and necessary is pretty much, even though every one of us is moving forward and is working hard on building better and better modularity into this quantum computing stacks, but until now, the transistor of the quantum era has not yet arrived. Everyone here in this community and out there is aware that there are quite a few qubit platforms are competing with each other. And why is that also, without going into too much detail, is that each individual qubit in a quantum processor still has too much personality and is kind of having aspects in lithographic variations, kind of defects in the materials, imperfections, and so on and so forth. And quite a few things have to happen actually to improve this kind of condition. And we fully acknowledge that there is still a lot of science to be done by developing novel material combinations. What is also extremely important on a larger scale is establishing industry-grade manufacturing facilities for these qubit processors. And what uniquely is Orange Quantum System and focusing on is the acceleration of the QPU development cycle has to also increase, which in recent years also has been acknowledged by players like Intel and others, where they are also acknowledging that if we are not finding novel solution in test and diagnostics, we come into trouble when scaling up the quantum processors. So our core value here of Orange Quantum Systems, a startup which exists now for almost 2 years, is getting down the test time and diagnostics time for characterizing quantum processors. And this already here sees kind of data taken by experiments from the ImpaQt consortium projects, that we are able to gradually enhance complexity and gradually lower even the time it takes to characterize qubits and quantum processors. Our current product line is offering a wide range of products for specific needs. The kind of the workhorse or our high data highway is Quantify, which we developed together with Qblox. And to make use of Quantify, we offer an orange box as a base product, but importantly is that we are developing quantum device diagnostic toolboxes where you kind of get your characterizing your qubit faster and better by not reinventing the wheel, but just using our experimental libraries available. If you want to have a complete system which with integrated hardware and software solutions, then I advise you to look into our offerings of Orange Rex. So what is the contribution of Orange Quantum Systems to ImpaQt and NanoNISQ here is this time, this is also an interesting aspect. System integration and project management was taken up by our company, but also strongly supported by Dan from Delft Circuits, also on the project management. So there it's a good example how even independent companies were able to sharing certain aspects of tasks which have to be done in getting such a complex project off the ground and make it successful. On the more concrete scientific or engineering level, we are working on the characterization, tune-up, and diagnostic of the quantum processor. And what's also interesting, and that was kind of bringing the huge bow to the beginning of what Dan was mentioning, we are even able to have a full stack available and to make use of the system for verification of the individual components by experiment. Where are we now? Is we are extremely close to execute our first NISQ algorithm. So we have a single qubit and 2 qubit gates in our quantum processor observed and kind of tuned up to some extent. And we can also later on explain a little bit more detail how the project of ImpaQt is being delivered currently in the TNO kit facility. But our next rounds of experiments will begin in 2 weeks from now, where we will expect to first get a 2-qubit nano algorithm off the ground, and then the full-fledged 5-qubit nano-NISQ algorithm should be executed. And with this motivation, I will hand over to Mario from Pascal, and he will explain us what is the final result, what we want to see.
Yes, thank you, Thorsten. Hope you hear me well. So actually, I'm Mario de Grada. I'm working at Pascal mostly on quantum solutions and product development. And Pascal is a company that is based in Paris that is working on developing neutral atoms platforms. But as some of you might know, actually it merged a few months ago with Q&Co. That was a former quantum algorithm company, the quantum algorithm developer company based here in the Netherlands. And actually Q&Co, whose name you might have been seeing also before in the slides, have been actually present and involved with the ImpaQt consortium and the nano-NISQ project from the start. So on the algorithmic side, we are focusing mostly on algorithms related to quantum chemistry and multiphysics simulations. And for the nano-NISQ projects, we are in particular, we chose to actually focus on what we call differentiable quantum circuit algorithm that has been developed a little more than a year ago. And this algorithm actually is a quantum algorithm that is promising the possibility of solving differential equations, partial differential equations of quantum computers. And it also holds the promise of working with current days quantum processors with noise. Thus, it was one of the best candidates for putting it forward in the nano-NISQ project. And just a little bit of introduction, that partial differential equations are actually ubiquitous in a lot of fields of engineering and also fundamental science. And they have been used, and they are used like on an industrial scale in mechanical engineering, chemical engineering, in weather forecast, and even up to, for example, optimizations of traffic and logistics and many other things, and of course in a lot of fundamental science fields. So the importance of actually having an algorithm that can solve differential equations on a quantum computer is quite evident. So if you go on the next slide, please. So actually, once we chose what to focus on, of course, the main contribution that Pascal and formerly Q&Co gave and is giving to nano-NISQ, actually, it's all related to the algorithm itself and on how to best run it on the device that has been developed during the project. So the main contribution starts from the definition of like an industrially relevant use case, such as among the ones that I briefly mentioned before. And of course, after choosing that, we need to express actually the use case as a mathematical model, and in particular as a differential equation. But some efforts has been spent, of course, in defining a model that was simple enough, therefore not really close to the industrially relevant case, but simple enough to be executed on a current day quantum processor, thus actually being able also to gather nice results from the on the device developed during the project. And once the mathematical model, so the differential equation was chosen, the contribution we had was mostly on the quantum circuit design. So basically designing with the expertise that we have in-house, designing a quantum circuits that was the most amenable for execution on the nano-NISQ device, quantum processing unit, and then of course the lion's share of our contribution was in the actual algorithm implementation. And there has been a lot of work on the implementation and also together with the other partners in the optimization of this algorithm for the actual device in order to get the best results out of it. And this is also, it will be followed and has been followed, of course, by several preparatory simulations, so executed with standard simulators for determining the best parameters, such as the number of shots needed for QPU execution, and then, of course, support for the QPU execution and results gathering and analysis. So basically, it's the full-fledged loop from differential equations to results on a current-day quantum processor developed during the project. So with this, I think I'm leaving the floor to Thorsten for some concluding words. Thank you.
Exactly. Well, we are quite impressed that we all managed to kind of one after another were able to show what we are working on together and how we kind of are able to put our components to work with clear defined interfaces. It pretty much seems to work. I just want to kind of get the opportunity to summarize what you have seen. Probably some of you for the first time is this Nano project was kind of bringing together. Well, Mario was a little bit under the radar, but it was an award-winning algorithm he is planning to execute here in NanoNISQ, and we showed that high-tech companies like Demcon are able to provide custom shielding and sample mounts. We have seen that high-end RF control systems are being developed here in Delft by Qblox. The 5-qubit quantum processor from QuantWare was introduced. Orange Quantum Systems showed some basic characterization to be completed, and the whole team is now ready for gate tune-up in the upcoming weeks. And with that, I would like to thank you for this presentation, and we are open for discussion and conversations.
Thanks very much, Thorsten, and thank you all the speakers. That was really great insight into what you guys are doing in this program. I forgot to mention at the very start of the talk, for anyone watching this on YouTube, if you have any questions for any of the speakers, please put it in the chat function, and then we can see it in the studio, and we'll bring those questions into our discussion. Before we go and I introduce our panelists for the discussion, I just want to ask a quick question, and maybe this will be to Dan and maybe Thorsten. The origins of ImpaQt really came largely in Delft and obviously in the Netherlands. I'm curious, what function do you see this ecosystem that we have here in Delft, this concentration of startups, which in reality is quite rare to have so many startups in one place? How do you see that has played a role in this initiative? I mean, I know a lot of the companies here, they collaborate internationally, they have partners all across the world, but this kind of initiative is very locally born. Is that how you see it, Thorsten?
I can make the first attempt. So I'm not Dutch, I'm coming from Germany, but even my generation, what we observed for 30 years, there was a concrete, you wouldn't call it roadmap because it was never written down, but quantum transport was always core and center in this environment where, when I come back to 1989, where quantized conductance in a one-dimensional channel was discovered. And since then, for non-experts, I think the experiments have never changed. And that, broadly speaking, I think I get a lot of bad words later on from experts, but that of course helped to clearly characterize weaknesses or even opportunities to bring certain aspects to the level of prototyping and towards commercialization. I don't want to go too much more detail, but that's pretty much the bigger picture from my perspective. Dan, do you have something to add?
Yeah, well, maybe very much from the ground. I think it was back in 2019, and then there was Qblox and Delft Circuits. And at a certain point, we said it was actually, well, there's been a lot of talk. It was Adrian and me. So Adrian is one of the co-founders also of Orange Quantum Systems. We went for a walk, and we grabbed a notebook, and we said, let's just draw this. We call it Delft quantum computer. What do we need if we're going to make it? and Adrian was still doing his PhD and was thinking what he would do and was thinking about characterization. And then we said, yeah, okay, we almost have all the components complete. That's quite a curious and very powerful combination. But what we really need is a chip. I mean, we also need a fridge, of course, but yeah, there's tons of them out there. You can get them. So we really need a chip. And that's the moment that at a certain point we really started pushing Alessandro, saying, Alessandro, you have to found a company and you have to make chips. And Alessandro was, I'm going to do it with these guys or with that guys or alone and all this stuff. And then eventually he figured it out with Matthijs and they did it together. But I think that was quite a nice moment. At a certain point, we literally sat down and drew the quantum industry of Delft, and it sort of happened to be like that. I mean, in a way, it was obvious you need these components, but yeah, that's how it went.
Great, no, that's really nice to know. We have one question coming from the chat, and it's from Harold, familiar to many listeners probably, who is one of the co-founders of Orange Quantum Systems. What is the next step for the ImpaQt consortium? Dan, can you give us some insights?
Yeah. Well, actually, I think it goes quite fast. So back a year ago, we were just doing this little thing together, and then we envisioned that maybe in the far future, someone would approach us and say, hey, this is a very interesting thing you're doing here. Can we maybe join, or can we maybe get your products, etc.? And now we see actually a lot of people approaching us who are interested to do that. So for us, there's really two things which we can do. And I will explain them both a bit. There's, of course, one thing that you could say, okay, let's form together something and start building quantum computers and sell those. And there's the other thing which you can say is, hey, let's stick to the spirit of the consortium where we make each other's products better and we test together. And I think that is really what we've decided to do. That's what we want to do, at least together. And then, of course, we have this roadmap of increasing the number of qubits, increasing the quality, but really making each other better as suppliers. And then on the side, there can be all kinds of other specific projects with external parties, or maybe sometimes a company pops up that purchases parts of the ImpaQt machine and builds a machine by itself and goes from there. But yeah, initially it's just keeping on this way, but really a sort of collaborative idea onto making each other's products better and setting the standards with that.
Nice. Torsten, anything to add?
Yeah, one thing to add is maybe is also it helps really to focus. I know people in full stack companies, and I appreciate what tasks they have in front of them. I'm really happy to kind of, with our company, iron out a certain aspect of this value chain and try to make it very good. And ImpaQt is a good vehicle for testing and improving and seeing what works, what doesn't work, and how to define interfaces more clearly.
Nice. Great. Thank you both. So I'm now going to introduce our guest to join our discussion. Jaqueline Schardijn. She is the Senior Business Developer at InnovationQuarter. Jaqueline, maybe you can give us a quick introduction to your interest in quantum and what role InnovationQuarter are playing towards the ImpaQt community.
Yeah, okay, thanks, Dan. Yes, I'm a business developer at InnovationQuarter. That's the economic development agency of South Holland. And I'm working in the digital technology domain. And my work is to build consortia with several partners together with academic researchers, also with government, and try to get innovations faster to the market. So that's my role. And I think it's now 5 or 6 years ago that I was interested in quantum technology. And I think it goes with ups and downs. And I think the sowing period took very long, but now, how we say it in Dutch, we can pick the fruits of it. And why we are very interested in quantum technology is, I think we have here in South Holland a great advantage. We have a good knowledge institution like QTech. We have also a growing ecosystem with many startups like ImpaQt, but there are still coming a few up, I know. And I think it's an early stage technology. We don't know where it's gonna go, but I think that's our role and also our duty to try to get also this very important upcoming technology quicker to the market.
Yeah, I mean, you and I have been working quite closely together over the last year to really frame the quantum activities occurring in South Holland. Obviously, it's not just Delft. We have Leiden as well as a knowledge institute and hub of quantum research. And the region have played the stakeholders in the region, the municipalities and other funding agencies have played an important role in the ImpaQt program. Can you give us a little insight there in the projects that have been successful?
Then I have to tell about 4 years ago, because quantum technology was not a focus topic, not for Delft and Leiden it was, but not for other municipalities and also for the province it was. And that's not strange, because it's a new technology, and a lot of people thought it's bridge too far, and they didn't have a clue what the impact could have for several sectors. So I had to convince first the province and also municipalities, because they wanted to know what is the technology level, readiness level, what's happening, which companies are already interesting and investing in this technology. So I suggested to do research. So we hired Birch, and the province, municipalities and IQ financed this research. And I think this report was very impressive and also important, because it gives answers to their questions, but also how we can capitalize the opportunities in the region. And that was the first step, I think, for the province and the municipalities to also come together to build an action plan we now have. So I'm very glad that we did this work.
Yeah, and I advise anyone watching it that's interested in this kind of regional development of quantum to keep their eyes on the Quantum Delft LinkedIn site, because there'll be plenty more news about that over the next few months. My next question would be, and maybe we can bring Mario into the conversation now from Pascal. I mean, obviously in Delft, we're quite hardware focused, and a key part of attracting or engaging industries in the region and generally into quantum technology is understanding the end users part of this. And I'm curious from the Q&Co / Pascal perspective, how do you go about engaging with industries who are perhaps not that familiar with quantum? They don't really understand it. How do you go about that?
Yeah, absolutely. So actually, this is true. There are still like several industries that are not really using quantum a lot. So the actual approach that we are following with most of our customers is sort of twofold. On one hand, we are like providing and training and also better understanding of the quantum domain. And on the other hand, we are helping them, and we are collaborating and co-developing with them specific solution tailored for their specific industrially relevant problems. And basically this is helping us to gather a lot of knowledge in advance. So before actually that we get quantum advantage, that we will be able to really solve those problems and give business impact of what are the problems that people want to solve. Because this is one of the most important conundrum, I think, in this moment of the quantum computing industry, that the actual use cases that quantum computers can really solve have not yet been really developed and understood well. So this is mostly the approach that we are. This twofold approach is what we are really trying to follow with most of our clients and partners, basically. Yeah.
And how is the market right now? Is it a case of you're connecting with industries, with partners to offer your services, or is it a case there's enough interest in quantum that you are really occupied with the current workload?
In this moment, the interest in quantum is rising quite a lot, as you can imagine, also from the news and from what is going on. So everyone, at least in my feeling, from when I joined the quantum computing domain a little bit less than 2 years ago, so I'm quite fresh. But actually, I can see that the interest in it is rising, and there are a lot more companies that are open to experiment with it, and that are convinced that this will actually give a business impact in the quite near future. So in this moment, yeah, we are seeing quite a lot of interest on that side. And I think this is good, but it's also the moment where we need all together also to really push forward and understanding better use case, such that we will be ready when quantum advantage is there.
Yeah.
And Dan, can I add something? Maybe it's good to share the link of the Birch report, because in this report there are also suggestions for relevant proof of concept for several sectors, and I think it can be beneficial for some people who are watching now.
Absolutely. We'll put that in the YouTube chat afterwards. We'll also put it again on our LinkedIn site. Thanks, Jaqueline. I think you hit the nail on the head, Mario, by saying it's about education. And I think we've had in one of our previous sessions, Quantum for Business. It's a new initiative that obviously InnovationQuarter are a key part of, to kind of help give companies that insight into what quantum is and what the potential opportunities could be in the future for their companies. And I think that's a key initiative, not just in the Netherlands, but internationally, that is needed to really help connect companies to the opportunities that are going to arise in quantum. But maybe... Thanks, Mario. I think maybe if we could move on to Vincent, if he's still available. I'm curious because all the other partners in the ImpaQt consortium are startups, whether they've come out of Delft or Amsterdam and the merger with Pascal. Demcon are a much bigger company, as you told us, Vincent. And how do you see the interaction with startups? Is it kind of just like an experimental kind of playground? Let's see what kind of happens, or is there a bigger view? Sorry, you're on mute, Vincent.
Excuse me, Dan. Then, well, the fun thing actually is that Demcon is big, but Demcon in Delft is actually quite small still.
Yeah.
So we are about 50 people. If you count the startup companies within the Demcon group, we are a little bit large, but also still small. And what I see is actually that we still have this startup vibe within the company, and that really helps in participating in these endeavors. So we do not really feel this big company drive amongst us, but we do have the support in the backup, from the larger company that helps us out. So that's what we do. And you say playground. Well, from the Demcon perspective, being largely aimed at being a mechatronics company, my personal drive is to put a little bit more physics into it and to see what we can do together, and also to be not a playing ground, but a breeding ground then for people rolling out of university. And we work for large companies like ASML, you name it. That's nice. It's important for us. But the fun thing is also being able to work with this smaller endeavors and to see what we can add. And I think, but the others may judge that more than I do, that we as Demcon did a good job in helping out the consortium.
Nice.
In the longer run, I think for Demcon it would be nice if we could get sort of a role in the quantum world within Delft, together with these guys or with other people. And so this is just a step up for that. So it's not well architectured. It's just a matter of going there and being able to supply and enjoying the ride as well.
Nice. And I guess that's really at the heart of what we want to do as an ecosystem. We're not just here for our just startups. We want this community to connect beyond our own little pond. And yeah, Demcon's almost the first example of connecting to another local industry player to really get involved into quantum.
Exactly, and what I can add finally is that we have a couple of for us it's a very small project, but we have so many people at Demcon who really like to work on this stuff. It's amazing to see, and they connect so well with the other people in the consortium, and that's something actually I'm really proud of.
Nice. That's really good to hear. Yeah. Thanks very much. Given the time, we've got a few minutes left until our hour is up. Maybe I can ask Julia if you can add in Dan and maybe Thorsten and bring Vincent back and keep Jaqueline. Maybe I can ask you all for maybe one kind of call to action. What you think about the initiative, what you want to see happening in the immediate future, either for the ImpaQt or your own company or the ecosystem more broadly. What would you like to see happen? I'll go to Thorsten first.
Okay, very simple. We internally at ImpaQt define usually goals we want to reach and the nice to haves and the great goals. So to be ambitious always in our projects. And what we have to admit, up to this point in time, we never reached the optimal goals we set ourselves. So maybe even we will be able to do that in NanoNIS, but it's still unclear. So the next step would be step up in performance and try to get the maximum out of our project, what we want to set ourselves.
Nice. Jan?
I think for an industry, repeatability and quality continuous, and not just one shot and a lucky shot, or we don't even know if it's a lucky shot, actually. It's just, and it's one. So I think for the longer run, multiple different chips, multiple different cables, different setups, etc., to really show that it's not a one-off, but we actually can do it continuously. That would be a very nice add-on also for ImpaQt.
Nice. Vincent?
Well, I would like to see the consortium staying together and picking it up and building really a quantum hub within Delft. And I realize that Demcon is a bigger player in the field, but I want to reassure everyone that we are not going to push anyone away here. Just going to be supportive, be a supplier for this world. That's what I wanted to add.
Good to know. Thanks. Jaqueline, over to you.
Yes, my final statement is a call to action to all companies to be curious about this great technology, learn together, see the Quantum for Business side, prepare yourself for the future because quantum is coming.
Excellent. Yeah. Well, that just leaves me to say thank you to all our speakers here on the screen and those earlier who we didn't get back into the discussion. Really appreciate you all joining. Here they all come. Hopefully we have enough space for everyone. Yeah, really appreciate it. It was great to get the update. And yeah, look forward to hopefully having you all back in a year's time with 100 qubits working and up and running and selling systems to the world. Thanks, everyone. Have a great evening. Take care.
Thank you very much.
Bye.
Thank you.
Thank you.